those notes, go through the problem steps, and if you have any doubts at any point of view, you can ask me at get clarified regarding your doubts, students. Okay. Now, one more point which I would like to highlight you here is we will be now going to module number 5. So module number 5, students, it is with respect to compressors topic. So has anybody seen where the compressor machines are used? Can you give some examples where the compressor machines are used? Can anybody quote? Where are the compressor machines used? Example for compressors, or where you have seen the compressor, students? Some examples according to you, where you have seen the compressors, or where we use the compressors, for what applications we are using the compressors. Compressors, yes, students. Hello? Is my voice audible to you clearly?
Yes, sir.
Give the example for compressors. Hello, compressors. So, where you have seen the compressors? Where you have seen the compressors? Where you have seen the compressors, or in which purposes we are using the compressors? Example for compressors. Can anybody quote these things? Where you have seen the compressors, or where you have used the term compressor? Example quote. Example for compressor, students. Hello? Hello? Is my voice audible to you clearly? Compressors nodiri. Where you have seen the compressor, students? Or for what purposes you are using the compressor?
To apply pressure, sir.
Apply pressure, right? This is one part. So you are applying pressure for various purposes. If you have seen in the city buses, KSRTC city buses, you can see there is a small pneumatic machine which is compressing the air by which the doors can be opened or closed. You have seen this part. Again, apart from this, students, ಇದೆಲ್ಲ ಮತ್ತೆ ನೋಡಿರಿ. For filling the air in your tires, we use the compressor itself, right? ಹೌದಲ್ಲ?
Yes, sir.
Then again, for various purposes in the industries to operate the machines now everywhere, the hydraulic cylinders we are replacing by pneumatic cylinders, which means the compressed air plays a very important role in compressing the it may be the water or air also. So no need not be only air itself. Sometimes there are water compressor machines are also there in the industries. So very important for you, you should know that these compressor machines which we are observing carefully, they are playing a very important role in the industries, especially from the point of view of application purpose. The point of view of application purpose. So I would like to say that when we are using the compressor, we should know which type of fluid is present in the compressor and how it can be compressed. So generally, when the compressor we are using here, students, for various applications, as I said, we may use it with respect to the compression of the air or any other fluid also. So that should be very important to you. I hope this point is clear to you now. So is my screen visible to you clearly?
Yes, sir.
Okay, so I think my screen is clearly visible to you. So as I said, we'll be discussing the compressors. So in the compressor, students, we are having two types, especially the rotary compressors and the reciprocating compressors. So mainly reciprocating compressors is there for your syllabus now here in the ATD subject. And here in this particular subject, you will be learning especially how the air is being compressed, what is the working fluid which you are using in the compressors for this semester study, and you will be learning the things, especially that how this air it gets compressed, and after compression what happens to its pressure, and why this compression is necessary. Is it can we not use other machines except of compressor? So those things we will be discussing here. Okay, so now I think everybody has learned the four strokes in an IC engine. Can you name those strokes? Can you name the strokes which you have learned in an IC engine, students? Hello? Can you name the strokes which you have learned in IC engine, students?
Suction stroke, compression stroke,
Students,
power stroke.
you have learned strokes in an IC engine. You have a stroke or four stroke engine. Hello? Students, am I audible to you all clearly?
Yes, sir.
Hello? Students, there's a problem due to which the connection got cut off. I'm very sorry due to network problem. I have reconnected just now, so again I'll be recalling the things what we were discussing. So as I was saying, the part students regarding the use of compressors, just I will be highlighting the things that the compressors are the machines especially which we are using them for compressing the air itself. Okay, and the very important part from this one is that in the industries, we are using the compressed air for various applications. It may be for the manufacturing purpose, production purpose, or even in the vehicles we are using them for movement of the transportation purpose, or for opening and closing of the doors, and for many other applications we are using the compressed air itself. So the compressed is nothing but it is a work done on a machine, and for this purpose we need to know things. Am I audible clearly, students? Hello?
Yes, sir.
1 minute. My screen has got stuck. I will display the PPT. Yeah. Is my screen visible to you all?
Yes, sir.
Okay. So as I was saying, compressor is a machine which is especially used for compressing the fluids from a lower pressure to higher pressure, and what required pressure it can be delivered for application purpose. So in the compressor, you may compress any of the fluids, that is maybe the air, water, or any compressor and chemicals also, depending upon what applications you are going to use it. Okay. Now, if you observe carefully, students, this compressor also, which you are seeing here in the sketch right now, if you observe in the sketch right now, it is also consisting of the same things that we have learned. That is the use of the suction stroke, compression stroke, as well as exhaust stroke. So if you observe here in this particular sketch, students, you can see here carefully that it is consisting of cylinder is there. Inside the cylinder, you are having a piston. You can see here this is a piston. Then this piston is connected with a connecting rod. You can see here. Then you can see here we are having two valves. One is known as the inlet valve. You can see here, and then is the outlet valve, which means more or less it is functioning at the moment of the fluid getting in and going out. It is more or less similar to that of an IC engine itself. Okay, so as these are things I would like to tell you that for your syllabus you need to learn only regarding how a reciprocating compressor works, and how the air is being compressed, and how it is useful for delivering it to the required higher pressure. Okay. Now, if you observe here carefully, students, at the side I have drawn a PV diagram, pressure volume diagram in the figure number B. Is it visible to you? Figure number 2. Figure number 2. Now, if you observe this PV diagram, students, carefully, you can see that pressure P1, which means this is the pressure, atmospheric pressure, or you can say that the pressure which is entering into the cylinder through the rod, through the inlet valve. So as the inlet valve starts to, that is the piston starts to move from what position we call this one in the cylinder, we call this a TDC position, and the piston moves towards away from the TDC, and this here which position towards it is the BDC position. So as we are describing here, I would like to say that as the piston travels slowing from TDC to BDC position, there is a pressure difference created inside the engine cylinder. Because of this pressure difference created inside the engine cylinder, the fresh air is taken inside the cylinder until the piston travels from to the BDC position, during which the air is being taken here, which is shown by the line C21. C21 you can see on the pressure volume diagram, students. If you observe on the pressure volume diagram, this particular line, students, C21, this is nothing but representing the air entering into the cylinder during the suction stroke. Is it visible to you, students? Is it visible to you? Now, this what happens here, the air is taken into the cylinder, its pressure until the piston reaches the BDC position, its pressure is constant. Its pressure is constant. How much is that pressure? The pressure is P1. Now, once the piston reaches the BDC position, then from there what happens? Again, the piston starts to move towards the TDC position. Let's see. Now I'm showing the movement of piston. It is now coming from BDC towards TDC position. Towards TDC position. As the piston is traveling from BDC position to TDC position, you can see the air is being compressed. And this air which is being compressed, if you observe, it is compressed by which process? It is compressed by polytropic process. Polytropically, the air is being compressed. So therefore, when the piston travels from the BDC position to TDC position, students, keep in mind the compression of air takes place by polytropic process. By the time when the piston reaches the TDC position, you can see its pressure now it has increased from P1 to P2. It has increased from P1 to P2. So therefore, the pressure is increased from P1 to P2, and from position 2 to D, what happens here? The air is going out of the cylinder. That is, we call it as the delivery stroke. This is the delivery stroke 2 to D. So the air is now delivered from the cylinder. Its pressure is P2, and from 2 to D, whatever you are seeing, its pressure is how much? Its pressure is P2 itself. So always remember, students, in the reciprocating compressors, we are having suction, compression, as well as the delivery stroke. So here, the very important point is the air gets compressed from lower pressure to higher pressure using which process? Polytropic process, that is P into V to the power of N is equal to C. P into V to the power of N is equal to C. Compression takes place by polytropic process. I hope this point is clear to you, students. I hope this point is clear to you. Now, the next important thing is S. These are the things which I was telling you. Once again, I will be highlighting the things here in this particular graph once again. So, what I was saying, students, the suction stroke, what we call it as? We call it as from the process C21. So, this particular process, students, C21, what I'm observing, it is a suction stroke. So here the inlet wall opens and the air enters the inlet wall until the piston reaches the BDC position, and it takes place at a constant pressure, what? P1. Then, students, as I said, from 1 to 2, the compression of air begins, due to which the pressure increases from P1 to P2. So this compression of air, it happens to happen here from 1 to 2, and it is taking place by which process? By polytropic process, which means it's an polytropic compression process. Then, apart from this, the next important thing is, once the air is being compressed from P1 to P2, then next it has to be discharged, it has to be taken away from the cylinder, and it takes place by process 2 to D, which means the air is being discharged from the delivery wall at constant pressure P2. And finally, once air is being discharged, the piston again, that is, there is no air in cylinder, the piston returns to suction stroke through this particular process, students, that is this one. You can see here C to D. The piston regains back its position towards the suction stroke from the process D to C. So therefore, these are 4 strokes you should know, understand whenever compression of the air takes place in the reciprocating compressor. I hope until here you have any doubts you can ask. ನಿಮಗೆ ಏನಾದರೂ ಗೊತ್ತಿರಲಿಲ್ಲ ಕೇಳಬಹುದು. Am I voice audible to you all clearly? Am I audible to you all clearly?
Yes, sir.
Okay then. Shall I proceed further?
Yes,
Now,
sir.
work done expression without clearance volume. So what does this mean, students? So if you observe the pressure volume diagram, students, carefully here, if you observe this pressure volume diagram carefully here, so this is the curve traced for the compression of air. You can see here, this is the curve traced. So I am highlighting this particular curve. Can you see it carefully? So, if you observe process D to C, is it a pressure volume diagram on the vertical line of the graph itself? Pressure curve C to D or D to C. If you observe from D to C, where is this line? It is merged on the pressure graph itself. Can you see it? What it means here, there is no clearance volume left for this particular class. Clearance volume illa. So if there was clearance volume, what would happen? It would not come on this vertical graph, that is on the pressure graph. So therefore, we need to calculate one work done expression when there is no clearance volume in a compressor. So therefore, how we can write here this one? The work done per kg of air for a reciprocating compressor, it has to be calculated by adding the areas of the PV diagram. So what are the areas? Please observe here, students. And here very important is, it is a work done on a compressor, which means it is a work input machine. It is a work absorbing machine. Okay. So therefore, what are the things we need to understand? Work input, how we can need to find out area under the curve C1 to DC. So where it is C? C1 to DC. This we need to find out. The area of this particular curve we need to find out. And to find out the area of this particular curve, what we need to do? So that is first area. This one, see here, observe carefully. That is equal to area 2DOBO2. This one, students. This one, please observe here. This one, 2DOB2. This area, as well as the next area, students. That is this one, 1-2BA1. We need to add both these areas. We have to add Martin. That is 1, 2BA1. Both the areas I have added. You have to add Martin. And in this area, students, what I am going to do? I am going to subtract. I am going to reduce which particular area? This particular area. That is 1COA1. This one, 1COA1. This is the part which I am going to remove. So ಇದನ್ನ ಫೈಂಡ್ ಮಾಡಕ್ಕೆ ಹೆಂಗ್ ಮಾಡೋದು? ಎರಡು ಆಡ್ ಮಾಡ್ತೀನಿ ಫಸ್ಟ್ ಗೆ, ಆಮೇಲೆ 1COA ಮೈನಸ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ I am going to get area under the curve, that is 1-2DC1. Okay. So now separately first in ಮಾಡೋದು area find ಮಾಡಕ್ಕೆ ಇದೆ. So now what I will do separately, I will start finding the area. First one, students, if you observe carefully, area under the curve. Area under the curve 2D0B2. This one. 2D0B2. Area under this curve. Note, if you observe carefully, students, the area under this particular curve, how it is like a rectangle. It is like a rectangle. So it is rectangle is what, students? It is a constant pressure process, and for constant pressure process, what is the word equation you are going to write? For a constant pressure process, what is the order equation you are going to write, students? In the order equation for a constant pressure process, students. Hello? For a constant pressure process, what is the order equation you are going to write, students? Am I audible to you? Hello? It is just from pressure P2 up to volume V2. So I write it as a word only. P2 V2 is my word and expression for this particular rectangle, which I have shown here. That is P2 V2. It is just a flow work which is occurring at a constant pressure P2. It is just a flow work. So now this is over. The next thing is area under the curve 1 to BA1 area under the curve 1 to BA1. So for this area under the curve 1 to BA1, please observe where it is 1 to BA1 for this particular process, students. 1 to BA1. So if you observe, there is nothing but your PDB work, displacement work, and here it is a compression process. So therefore, I will be writing this equation as minus PdV. Compression. So direct I will write the displacement work as minus PdV, or I can write this quality process as minus P2 V2 minus P1 V1 by n minus 1. Then you have to add the next, which is remaining, students. The remaining thing is this one, that is for the area under the curve 1COA1, this one origin. Okay, this one 1COA1, this is one. And if you observe, this is also one flow work itself, that is P1V1, so it becomes P1V1. Flow work during section at constant pressure, it is P1V1. So therefore, P2 V2 plus your displacement work minus P1 V1 would give you the word and expression without the clearance volume. So now how does it look? Let us see here now. So if you observe carefully, I am adding all those equations together. So you can see here is flow work P2 V2, then negative work P2 V2 minus P1 V1 by n minus 1 minus the flow work P1 V1. So if you take these together, I can write as P2 V2 minus P1 V1. So what I can write, I can take this common together. So then please observe here. What I have done is I have taken these together and framed, and I have taken these two as common, P2 V2 minus P1 as common. So the common I get 1 plus 1 by n minus 1, you can see here. On simplification, this becomes n by n minus 1, P2 V2 minus P1 V1. So as we are using air as our working fluid, you can use the gas equation, that is PV is equal to mRT, or you can write it as n by n minus 1 mR into T2 minus T1 kilojoules per cycle, or n upon n minus 1 mR into the second rate T2 by T1 minus of 1. So therefore, what I can say is T2 by T1 is equal to P2 by P1 raised to the power of n minus 1 by n, or work input as n by n minus 1 mR T1 into P2 by P1 raised to the power of n minus 1 by n minus 1, or I can write it as n power n minus 1 mR T1. Pressure ratio, this is the equation, students. I can write it as in this form also. So work input equation, you can write in any of these forms. I hope this point is clear to you. If you have any doubts, you can ask here, students. Hello? If you have any doubts, you can ask here, students. Any doubts? No doubts? So once again, I will explain this derivation. Please go through here, because it is a basic derivation and once you understand this one, then only you can solve the other problems. Okay, so once again I will tell you how we are calculating without clearance volume. So please observe here, this is first step. We are going to add this flow work, that is 2DOB2. This is the first we are going to add, and along with this, what we are going to add, the next one is this one, 1 2 BA1. This we are going to add. This is 1 plus 2. And in this, what we are going to subtract? We are going to minus this one, students. That is 1 COA1. This we are going to subtract. That is number 3. So this is nothing but 1 plus 2 minus 3, which will give you this curve. This curve you will going to get, that is 1 2 then DC. This curve you are going to get. Okay, now as I was saying this thing for you, what is process for 2D0B2 curve? It is flow, that is B2B2, which you can see here. I have highlighted this as B2B2. Then the displacement work is the negative work done on the machine, that is minus PdV, and as well as the flow work as P1 V1. Okay, now if I combine them together, what I get, I can write as P2V2 plus P2V2 minus P1 by n minus 1 minus P1 V1. So if I subtract, if I take them as common, I can write as P2V2 minus P1 V1 by into 1 by n minus 1 plus 1. So on simplification, I can write it as n by n minus 1 P2 V2 minus P1 V1 in terms of kilojoules per cycle, or PV is equal to MRT. This is the equation, that is your gas equation. So I'll replace MRT2 minus MRT1, or if I take T1 as common, I can replace T2 by T1 minus 1. So for a polytropic process, this is the pressure temperature relation equation. For a polytropic process, this is the pressure temperature equation, that is T2 by T1 is equal to P2 by P1 raised to the power of n minus 1 by n. So I am replacing this here, that is n upon n minus 1 into mr T1 into P2 by P1 raised to the power of n minus 1 by n minus of 1. Okay, so this is a work input expression for a reciprocating compressor without having any clearance volume. Suppose if you have any clearance volume, what happens? Please observe here, students. If you have clearance volume, so now if you observe in this particular picture here, if you observe here, this is the work done expression curve, illodry. You can see this is the work done. ಆಗಲೇ ಇದೇನು ಕರ್ವ್ ಇತ್ತು 3 to 4, ಇದು ಕೂಡ ಮರ್ಜ್ ಆಗಿತ್ತು, ಗ್ರಾಫ್ ಕೂಡ ಮರ್ಜ್ ಆಗಿತ್ತು, ಅದಕ್ಕೆ ಕ್ಲಿಯರೆನ್ಸ್ ವಾಲ್ಯೂಮ್ ಇತ್ತಿಲ್ಲ. ಬಟ್ ಹಿಯರ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ನೋ ಕ್ಲಿಯರೆನ್ಸ್ ವಾಲ್ಯೂಮ್. ಹೌ ಮಚ್ ಕ್ಲಿಯರೆನ್ಸ್ ವಾಲ್ಯೂಮ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಹಿಯರ್ ಫ್ರಮ್ ದಿಸ್ ಪೊಸಿಷನ್, ಇಲ್ಲಿಂದ ಹಿಡ್ಕೊಂಡು ಇಲ್ಲಿ ತನಕ ಎಷ್ಟು ಕ್ಲಿಯರೆನ್ಸ್ ವಾಲ್ಯೂಮ್ ಐತಿ ನಿಮ್ಮ ಕಡೆಗೆ. ಓಕೆ, ಸೊ ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ಹಿಯರ್, ದಿಸ್ ಮಚ್ ಈಸ್ ದ ಕ್ಲಿಯರೆನ್ಸ್ ವಾಲ್ಯೂಮ್. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲಿಂದ ಹಿಡ್ಕೊಂಡು ಇಲ್ಲಿ ತನಕ ದಿಸ್ ಸ್ಪೇಸ್ ಈಸ್ ಯುವರ್ ಕ್ಲಿಯರೆನ್ಸ್ ವಾಲ್ಯೂಮ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ದಿಸ್ ಈಸ್ ದ ಕ್ಲಿಯರೆನ್ಸ್ ವಾಲ್ಯೂಮ್. ಹಿಂಗ ಕ್ಲಿಯರೆನ್ಸ್ ವಾಲ್ಯೂಮ್ ಇದ್ದಾಗ ನಿಮ್ದು ಈಕ್ವೇಶನ್ ಏನಾಕೈತಿ. ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ ಹಿಯರ್ ನೌ. So this we call it as VES is equal to effective swept volume, and the area under the curve, ಯಾವ್ದು ನೀವು area under the curve calculate ಮಾಡ್ಕೋೈತಿ, you need to calculate for 1 2 3 4 1 on a pressure volume diagram. So work input is equal to area under the curve 1 2 3 4 1. Okay, so ಇದನ್ನ ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು ನಾವು? the same procedure what we are applying here, students, that is 1 2 E D. This is the area under the curve, and for this area we will be minusing, that is 3ED4, that is 3ED4. ಇದನ್ನ ಎಷ್ಟು ಮೈನಸ್ ಮಾಡ್ರೆ ಆಯ್ತು, you will get that particular area. So now if you observe very carefully, students, 4 to 1, if you observe, it is constant pressure process. Then this one, it is a compression process. 1 to 2, 3 to 4 again constant pressure process. Whereas 3 to 4, again it is what? Expansion taking place, polytropic process is through polytropic process. Okay. So now, how I can write here? Work input is equal to this area under this particular curve first. That is 1, 2, ED1. This particular curve. So again, now derive I have written n by n minus 1 P1 V1 into P2 by P1 n minus 1. Then divide work done without clearance volume. Other expression for this particular curve. Now in this what I will be minusing? Yav minus ಮಾಡಬೇಕು ಇದನ್ನ minus ಮಾಡಬೇಕು ಇದು. That is 3ED4 this one. ಇದು ಏನದು work done expression without clearance volume ಇಷ್ಟು minus ಮಾಡ್ತೀನಿ ಇದರೊಳಗೆ. So if I minus this area, what I'm going to get? That is P4 V4 by P3 by P4 raised to the power of n minus 1 by n minus 1. So this is the equation. Now I have got. So on simplification, what I am going to get? Please observe here. This one. So if you observe the graph carefully, 4 to 1 it is a constant pressure process. Do you agree? 4 to 1 is a constant pressure process. So P4 is equal to P1. Similarly, 2 to 3 is constant pressure process. That is P3 is equal to P2. So finally, how I can write this equation? Work input as n upon n minus 1 into P1 into V1 minus V4 into P2 by P1 raised to n minus 1 by n minus 1. Or what is this V1 minus V4? Not V1 minus V4 on the end. It is what? Effective swept volume. Effective swept volume. V2 by P1 raised to the power of n minus 1 by n minus 1. So work input is equal to this much. Okay. So this is the work input expression with the clearance volume. So if you have any doubts, you can ask here, students. If you have any doubts, you can ask here now. Hello? Students, if you have any doubts, you can ask now. Hello? Hello, students, do you have any doubts?
No, sir.
Okay, then. We shall stop here the class. Okay? Thank you, students.